In this video, we'll look at convolution and the Laplace transform. We'll start by looking at two functions, ft and gt. We can simplify them as just f and g. And now we perform Laplace transform on f and g. The product of the Laplace transform in general is not the Laplace transform of the product. In another word, LF times LG is not equal to LF times G in most of the cases. Instead, LF times LG is equal to LF, some special operator, G. The cross and circle symbol is called convolution. If we put this equation into words, the product of Laplace transform is equal to the Laplace transform of the convolution, not the product. You may wonder what is convolution. We can write down the function ht, which is ft convoluted with gt. The mathematical expression of the result of convolution is integrate from 0 to t, then f tau gt minus tau d tau. This is the mathematical expression. Then what is the physical meaning of convolution? Convolution is a measure of overlap of two functions. If there's zero overlap, the convolution is 0. If there's perfect overlap, the convolution will be 1. Here is a good illustration of convolution from Wikipedia. You have the f tau, which is the blue square, and gt minus tau, the red square. The black line measures the degree of overlap. When there was no overlap, it was at 0. When there was a complete overlap, the value is 1. Convolutions kind of everywhere in our lives. For example, if you look at a puppy, what you see is actually not the puppy itself. Our eyes can be considered as a lens system. What we actually see is the signals from the puppy convoluted by the imperfections of our eyes. That gives the final image. I hope that gives you some better understanding of the mathematical term convolution. Back to Laplace transform. In this example, you have hs, which is equal to 1 over s squared plus omega squared, then square. Then the capital Hs can be viewed as 1 over s squared plus omega squared multiplied by 1 over s squared plus omega squared. The question is to find ht. The h here is a lowercase h. From the very first video, we know by looking up the Laplace transform table, if you do Laplace transform of sine omega t, you get omega over s squared plus omega squared. Then sine omega t over omega will be the inverse Laplace transform of 1 over s squared plus omega squared. We also just learned that in the S space, if it's a product, then in the T space, it will be convolution. Then the lowercase ht is equal to sine omega t over omega convoluted by sine omega t over omega. Use the formula we had on the previous page about convolution. What we have here is 1 over omega squared. Then integrate from 0 to t, sine omega tau, sine omega tau minus t d tau. To proceed further, we need to use a trigonometry trick. From high school, we learned that sine x multiplied by sine y is equal to half minus cos x plus y plus cos x minus y. The x and y in this case are omega t and omega tau minus t. Then ht is equal to 1 over 2 omega squared. Integrate from 0 to t, then minus cos omega t plus cos omega tau, then d tau. The rest is just simple integration about tau. And the final answer is 1 over 2 omega squared multiplied by minus t, cos omega t, plus sine omega t over omega. This is the last video on Laplace transform. Starting from the next video, we'll look at linear algebra and the matrices.